Hello and welcome to the next edition of the BobCAD-CAM webinar series. Today's topic is 7 types of pocketing. Let's see. The goal of today's webinar is to learn about the 7 types of pockets and how to use them. As you know, my name is DePoalo. I'm the voice of the Bobcat After Dark video series. You can find me on Instagram at BobCAD-CAM, or you could also search hashtag BobCAD, hashtag BobCAM. So what are we going to learn today? Today is all about pocketing, 2D pocketing. We're going to go through zigzag, offset, advanced, adaptive, spiral, and rest roughing. We have a bunch of sample files here to go through, a couple to send in from some customers. So yeah, it's pretty exciting. As always with BobCAD, you can expect fewer steps, better cuts, and more profit. Now, we do have a webinar promotion. Today, you can take advantage of the webinar promotion. It's at 877-333-4903. Call us to find out more information. If this is your first webinar with us, if you have any questions in the GoToMeeting dialog box, there'll be a spot right here where you can type in questions. That is how you communicate with me. So if you guys have any questions, you would communicate right through there. Now, with the webinar promotion, it is a refer a friend webinar promotion. We ran it last week as well. It was super successful. A lot of guys took advantage of it. 877-333-4903. You refer a friend to us and you get a free seat of the software. Okay. All right. So let's give me just a moment to set up my screen here, and then we'll go ahead and get started. As always, if you could just do a quick shout out and let me know who you are and where you're from. It'd be great to see who's all with us here today. It looks like we got Bill in Texas, Reginald in South Dakota, Larry from Illinois, Murray out of Texas, John from Palm Harbor, Scott in Massachusetts, Jason in Ohio, Ray in Mississippi, Hugh in Michigan. I want to thank each and every one of you for spending some time with me here today. I really appreciate you sharing your lunch or your afternoon with us. Today is going to be a great webinar. We got Don out of California. We got Brazil, Shams in New York, Brian, same place, same some channel. Okay, very good. Again, I want to thank each and every one of you for spending some time with me here today. Now, the goal of today's webinar is to talk about pocketing. So we're going to talk about pocketing. If you guys have any questions about pockets, you want to go ahead and fire that away. Let's try to keep the topics or keep the questions on topic. But any question that you have is a good question. If I'm not able to answer it live, we can answer it at the end of the webinar. Or, hey, we have Chris in Arkansas on the Facebook. We got South Africa here as well. Thank you guys so much for showing up. I'll give you a little like there. Thank you so much. Thank you so much. I know that there were some questions about how BobCAD compares to some other systems. The best thing you can do is download a copy and see for yourself. We got John in Ontario, so thank you very much for everybody showing up here today. Okay, so let's go ahead and jump right into it. We got a lot of examples to go through. So the first one that we have here is just like a rectangular pocket. It's not really very complicated. We're gonna, I have a job set up here already. So we have a milling job. We've set our 0 at top center, but you can set your 0 wherever you want. Okay. You can right click here and you can load in your different machining features. So we're gonna do mill 2-axis here. So we'll go mill 2-axis. All right. This is the mill 2-axis wizard. So the wizard is, we're going to use this to answer all the questions about the machining cycle. So the first thing we're going to do is select our geometry. We're going to pick this face. That's the face that we want to machine. We're going to choose OK. We'll come to our machining strategies. We're going to go to our pocket strategy. From our pocket strategy, we're going to set up our tools. So we'll start with a 1/2-inch end mill, and then we're going to look at our patterns. Now, how you find out or how you change what type of pocket cycle you use is really about this patterns page here. And we're going to go through and look at the different options here. So we have zigzag, we have offset in, we have offset out, we have an advanced pocket, we have an adaptive pocket. So you got adaptive roughing. We have use spiral for circular pockets. Okay, and down here we have rest roughing. So when you're trying to choose which type of pocket cycle you're going to use, you're going to do that all from the patterns menu. Okay, the first one we'll look at is zigzag. When we're doing a zigzag pocket, this is a very traditional pocket. The tool is going to move back and forth. You do have some options here where it says final contour. You can do no profile, you could do a profile before, and you could do a profile after. So we're going to say do a profile after. We can look at our parameters. This is if we're going to leave any stock on the wall, if we're going to leave any stock on the bottom. This is if we want to take multiple steps. We can do it in a single step. We could do it in multiple steps. You also have your leads, how the tool is going to get into the material. You can have it do a plunge. You can have it peck to get into the material. You can have it ramp to get into the material, or spiral to get into the material. Once we have all of our settings set up, we're going to go ahead and hit compute, and then that will create some toolpath here. Okay. Now, if we go over our feature and we right click and we choose backplot, this will plot where the tool is. You're going to see how we're ramping down into the corner of the part here. So I don't really like the position that it's ramping in there. And then we're having it moving back and forth in a zigzag pattern to cut our pocket here. All right. Now, if we want to make any changes to our pocket cycle, we're going to just right click and we're going to choose edit. And then we can come back, and if we go to our patterns, we could change maybe the lace angle. Instead of it 90 degrees, we could change it to 0 degrees. We could recompute from there, and you can see how that changes the angle of the toolpath. Now, if we edit our feature here and we go to our leads, we could change the length of our ramp. So instead of it being a 1/4 inch, we could make it a 1 inch, and then that will change the amount in which it moves back and forth here. Okay, we could also change this from a ramp type cycle. We could also change it to a spiral type cycle. So this way it will spiral into the material. All right. So your zigzag is just a very common, very traditional type cycle. You may use this more for woodworking type applications, or it could be with metal applications as well. Generally, you can cut a little more aggressive. If you look at your pattern here, you could do a 75% or even a closer to 100% step over. So you can get very aggressive with your step over, and it's just going to work back and forth around the material. Now, if there's any questions about the zigzag pocket, go ahead and fire away. Otherwise, we're going to move into some of the other options here. So we have a zigzag pocket. The other style that you have is either an offset in or an offset out. In this case, I think it makes most sense to use an offset out pocket. So we're going to hit compute on this, and you can see we have our offset out. From here, we can backplot through here. It will start in the center, and then it's going to work its way out. All right, so that is our zigzag, and then we also have our spiral in, spiral out. Okay, so if there's any questions about that, go ahead and fire away. Otherwise, we'll move on to our next sample here. Okay, so whether you have a single pocket or whether you have multiple pockets, the workflow is really the same. We'll start a new job. We're going to run through our stock wizard here. We're going to indicate where our 0 position is going to be. Okay, once we have that set up, then we can come in and we can load in our cutting strategies. Hello, Mike, how we doing? Now, another thing you can do is you can take a feature from one file, and you could copy from one file, and you could paste this feature into another file. That allows you to save features and move them from one to another. Mike has a question. How can you control this step over to be consistent in the pocket? So I'm not, can you elaborate as far as how you're having it being inconsistent, or are you looking for a different, like consistent tool load or something along those lines? Okay, so again, we're doing an offset pocket here. We copied it from one feature or one part file. We opened it into another part file. We selected multiple boundaries here. We're going to choose OK, and then we can compute from here. So whether you're cutting a single pocket or multiple pockets, Mike's saying I use the percentage control, but it won't always be exactly the same. It's true with an offset routine or a zigzag routine, your tool engagement could be greater. What I would recommend you do, Mike, is you use the adaptive tool path. That will give you a more consistent tool path step over across your pockets there. Okay, so in our first routine, we have our single pocket here. We did a zigzag, we did an offset. In our second routine, we just have multiple pockets. So whether you're cutting single pockets or multiple pockets, you could use a zigzag. You could also use an offset out. Generally, if it's a shape like this, I'm going to do an offset out versus an offset in. If it's an offset in, I would generally be working from the outside in. Okay, so offset out if you're working from the inside out, like a pocket. Offset in if you had some kind of boss or something and you're working into it. Okay, all right, so we got those two there. Let's look at number 3 here. Number 3, we have a pocket with an island in the center. So we're going to go through the same workflow. We'll go ahead and create a new job. We're going to run the stock wizard here. We'll pick up our origin in the back corner. Okay. I'm going to paste my machining feature. I'm going to use my same settings here. I'm going to go ahead and select the face that I want to machine to. And then I'm going to click OK. And I'll compute my toolpath here. Yeah, I tried that. It would not do the internal pocket that way. I'll send you the file later. Yeah, absolutely. Definitely send me the file and I'll take a look at it. Mike says, how do I use cutter compensation, G41, G42 in a pocket rough before using the profile finish? It seems the only option is available in the profile finish in the stock wizard. And that is correct. Scott brings up a great point. Thank you, Scott. In our pocketing cycles in BobCAD, you're going to have your patterns and you're going to have your parameters. But there isn't an option for G41, G42. We do not post G41, G42 in your pocket cycles. We'll post G41, G42 in your profile finish. Okay, so we use the rough cycle to clear out the majority of the material. And then what you'll do is you'll load in a finish cycle for the wall. And you'll notice under the parameters here, we have some cutter compensation. Now, Scott, some customers like yourself would like to use a G41 or G42 in a pocket cycle. Now, it is possible to script in that functionality. You can see under this posting tab, this is a pull-down menu. You got a checkbox and an input field. Using our advanced posting tab, you could actually create a call for cutter comp so that you could use cutter comp in any cycle for that matter. It's not an in-the-box feature. It is something that you can add to the software using scripting. And it'd be great if you'd want more information about that, Scott, I can send you an email after the webinar and we can go through that. Okay. All right. So let's get rid of our finish pass here. Let's see here. Okay. So in this example, we have a pocketing cycle. We have a narrower section here. Yep, absolutely. Let's do that. Rick has a question too. First time webinar. Thank you so much for showing up here today. Can you change the full depth of a pocket and then next or same depth to each pocket? I'm not sure what you're asking here, Rick. If we come in and we edit our settings here, we can go to our parameters. And when you're dealing with multi-steps, you have either even depths or defined depths. Okay, even depths is going to give you basically the same, it's going to take the depth of cut that you enter, and then it's going to alter it so that you get an even number. So if I set this to 166 as my depth of cut, it actually will adjust it so that I get an even number of depths in order to get down to the bottom. Now, if I make it a defined depth and I set this to 166, then it's going to take 166 every time that it can, and then the last pass, it will take whatever's left over. And sometimes they call that an onion skin. So I'm not sure if that's what you're asking about the depth cut there, Rick. If you want to elaborate on that some more, that would definitely be helpful. So this way I get a better idea of what your question is, or to make sure that your question is being answered properly. Okay, very good. All right, so I'm just going to keep it at a single depth right now because what I'm trying to show here is where, generally you're going to try to use a larger tool. A larger tool is going to be more efficient in clearing the majority of the material. The only problem with that, like in this example here, we've used a larger tool to clear out the majority of the material, but you can see back in this section here, the tool is not getting inside of there, okay? And that is one of the types of pockets. When we're looking at 7 types of pockets and how do you use them? Well, if you've used a larger tool to clear out the bulk of the material, and then you have a smaller section that you want to target with a smaller tool, what you can do is edit your feature. You'll go to machining strategy, and you'll load another pocket cycle in here. Okay, so now you have 2 pocket cycles. And then from there, in the second pocket cycle, you can drop your tool size down so you can use a smaller tool. And then you can change your pattern, okay, from an offset pocket. I'm going to click on Advance. Okay, when I click on Advance, okay, by clicking on this section here, you'll notice this section comes up, and this is where your rest roughing is. So we're going to fill in that section here in just a second. Okay, so let me erase my drawings. We'll go back to a normal. So when you're in offset, you won't see it here. When you go to advanced, you'll see it pop up. When it pops up, you can set this to rest machining or rest rough, and what that will do is target where the larger tool wasn't able to fit. So now this smaller tool is going to come in here and it's going to clear up the material between this island and the wall here. And then you'll also see that it comes in because we have a smaller radius in the corner. So you're going to see that the tool will come in and clean up the corners as well. All right. So this is an example of using rest roughing. And rest roughing is a way for you to target material left over from a larger cutter, okay? If there's any questions about rest roughing, go ahead and fire away. Otherwise, we're going to move on to the next one. David has a question. For rest machining, can you define a second coordinate system to reference second tool to? Could you? Yes. You could. Can you explain to me why you would want to? In this setup here, this is our first setup, so that's our 0 position. This is our pocket 1. This is our pocket 2. If you wanted to set a different setup location, you could do insert setup. You could edit the setup location. So I'm going to put it on this other corner here. Okay. We have this feature. I'm going to copy it. I'm going to paste it into the second setup. Now it is, I don't know, are we still running 54 or are we running 55? I'm not sure. But if you copy a feature from one setup to another, it retains the initial setup value. Hello, Tom. How you doing? Hello, Alfred. Nice to see you. Zach, thank you for joining as well. Okay, so I have my first setup location here. I have a second setup or origin here. I will reselect my geometry. Okay, I'm going to edit my feature, and really I'm just going to get rid of the first pocket and I'll recompute. Okay, so what we have in this one here, I'll get rid of my second pocket and recompute. Okay, so what we have here is in the first setup, we're pocketing, roughing the material out. We'll blank that one out. And then in the second setup, we're coming in and we're rest roughing. I have no idea why we'd want to do that, but we are referencing 2 coordinate systems or 2 work offsets for each one of those. So yes, it is possible to do that. All right. If there are any other questions about that, go ahead and let me know. Otherwise, we'll move on to the next scenario here. All right. So this is another example of like an OpenType Pocket. This is where you want the tool to start in from the outside. Again, we'll run through the wizard here. So we'll set up our job. We're going to go ahead and set up our 0. Okay. I'm going to paste in my machining feature. Okay. I'm going to select the faces that I want to work with. So these are the faces I want to work with. I'm going to choose OK. I'll compute the first one, and we'll see we get some toolpath. Now, the problem with this toolpath here, the way that we selected our geometry, is we're going to see the tool, it's actually trying to stay within this boundary here. Okay, so it doesn't know that this is an open area at this time. The way that it will find out that this is an open area is when hopefully we're not frozen for everybody here. No, we seem to be okay. So hopefully that will free up for you there, Richard. But again, so we want to come in from the outside, but by selecting just this face, we're not able to come in from the outside. So what are we going to do there? We're going to have to change our boundary. So this is where we would create wireframe. And the reason why we're going to create wireframe is because we use a certain type of wireframe in order to set our boundary for an open pocket, or what we call an advanced pocket. So I'll create a new layer and make it active. I'll go to Utilities, Extract Edges, Single. I'll click on these faces here. Those are the faces I want the wireframe for. I'll hit my space bar to lock it down, and then I can turn off this other layer. And what that does is gives me the wireframe boundaries here. So now what I'm going to do is select these edges here as such, okay, and I'm going to convert them to dotted lines. And by converting them to dotted lines, that will let the software know that the tool is going to pass through here. Tom had a question about how he can get our software. Tom, if you call 877-333-4903, you can talk with an account manager, and they can help you get started with a BobCAD package, okay? 877-333-4903, 877-333-4903. You can call and let them know that you saw the webinar and you would like to get a copy of the software. No problem. Okay, so we have our open boundaries here. We're going to come back. We'll remove our selection and we'll reselect. So I'm going to select all of my boundaries here. If I recompute, nothing's going to happen just yet, okay? If I recompute, nothing's going to happen. In other words, it's not going to start off of this boundary. It's still staying inside of it. What I have to do is I have to change the pattern, okay? So I'm going to go to the pattern, all right? And I need to use this advanced pocket pattern, and that will give us working from the outside in. Hey, John, thank you so much for showing up. And Reginald, I have a video on how to do this. I know you run the BobCAM V5. I did do a 2D kickoff for SOLIDWORKS 2018. If you've watched that series, I definitely go over how to do an open pocket in BobCAM. So I would watch that. Hey, Ray, thank you so much for showing up here today. And it looks like Rich was having some issues with his internet connection. Okay, so I'm going to change this to an advanced pocket now. I will go ahead and recompute this. And then we're going to see the toolpath will change slightly. What it's going to do now is work its way in from the outside. So you can see now it's going to start off of the part here. Oh, let me turn that off. So it's going to start off the part, come down, and then it's going to work its way in and then reposition. And this is what we call open pocketing, and you do this with the advanced pocket toolpath. Okay, so we can close this down here. Again, if you're working with a scenario where you're trying to come in from the outside, what you're going to want to do is set up a boundary with a dotted line, and then the pattern that you're going to use, the toolpath pattern, is going to be the advanced pocket. So it's the advanced pocket here. That is what you use in order to get the tool to come around. Now, why does it always curl around? That's a great question. It has to do with the algorithm. And we have had some suggestions that have come in where sometimes, when it's doing this, when it's rolling around this edge here, it can be problematic for neighboring surfaces. Generally, what I would do here in order to get the roll around away from this edge of the part here is I would do like a stretch. So you can select multiple entities here as such. And then what you can do is just move the boundary out a little bit. And then that way, when it does roll over, it won't get in the way. Larry has a question. Would this same procedure work with leaving an island on a flat part? Yes, absolutely, Larry. That is a great example. Let me see. This is our next example. This is similar. It's not quite an island where we're coming in all together, but it is a case where you have this is a three-sided open pocket. Actually, this first one here, this is what I would call a one-sided open pocket. So what I mean by that is you can see how the tool is only coming in from one side. There's one side that's open. The next one that we have here is this one, and this is a two-sided open pocket. So you have an open side on this side, and you have an open side on that side. So that is also a very common scenario. The one you're talking about, Larry, is a four-sided open pocket where it's going to come in around all edges. So we did the first one here was the one-sided open pocket, and again we used our dotted lines to be able to program that. We're going to go through the same workflow for a two-sided open pocket. So we're going to do new. We're going to run our wizard here. We're going to set up our 0 position. Okay. I'm going to add a new layer here. I'm going to extract edges from here and from here. Okay. By extracting edges from those two sides, what you can do then is select these areas here, and we can make them dotted lines. So we say that's the open area. I'm going to paste in this feature. I'm going to select my boundaries. So I'll select this one and this one. In this example, let me get rid of the rest pocket here, and then we'll drop this tool size down. We can do an advanced pocket here. This one I'd probably do, because it's more slotting, I'd probably do more of an adaptive type routine. This is where it's going to, tricordial type machining, so it's going to work its way in. There are some tricks that I generally do here with a two-sided open pocket. You can see how it's going to come in from this side, and it's going to peel, mill, and work its way down the line. And then when it gets to this end, it gets a little bit weird here on the end. It does clean it up, but it gets a little bit weird. What I sometimes will do is actually just make it a closed pocket. So I'll move this one out a little bit, and then I'll trim these sections up here. So I'll trim from here to here, and I'll trim from here to here. Okay, and then what it does is what am I doing? It closes it off. So it closes it off on the end, and it's just a little bit different tool motion. So we'll leave one open, we'll leave one closed. Let me reselect the geometry to update for the change, and then we'll recompute. And you'll see how it will close off this end here versus the way you can see this one is working here. So again, this is an adaptive type tool path, so you can see how it will close off this end. A little bit of wasted movement there, but I think in some scenarios it's actually just fine to approach it this way. David had a question. Can you use this curve method to modify an existing part? The imported step is the stock piece you started with, and your sketch the part modification. Yes, you can. If you import, David, if you import a step file, you can bring in a step file, and then you can edit it. So yes, you could edit it within the software. So that would not be a problem at all. All right. So if there's any other, Raymond has a question about sketch. I'm not sure what that is, but if you could elaborate, that'd be great. Okay. So this is a two-sided open pocket. Let's go to number 6. This is a three-sided open pocket. So again, we're going to have the same procedure for open pocketing. We're going to load up our new job here. We'll set our 0 position. So we'll set our origin back here. All right, I'm going to blank out my stock. I'm going to paste my machining feature. All right, we're going to create a new layer. We're going to extract edges for this face here. All right, so that gives us our boundaries. We're going to come in here and select our 3 open edges. So it's this one, and this one. We're going to go to a dotted line here. So now we can see that these are the open areas that we want the tool to come in from. We will select our boundary. We'll edit our feature. All right, so this one, we're going to do an advanced. We're going to do an advanced pocket. We'll do the rest pocketing. Let's go ahead and compute this. All right, stretch. Yes, stretch is a way for you to stretch out your boundaries, rectangles and shapes. You'll find it under utilities and then stretch. It is important that when you stretch the geometry, you do so from a top view, and then it's also important that you do so that the geometry is flat in the plane that you're working in, okay? So that's what I would recommend there. All right, let's go ahead and stop for just a moment. Okay, and again, just real quick, we are doing a refer a friend promotion. If you are an existing BobCAD customer and you know a friend that is interested in the BobCAD software, if you refer them to us, you're going to get a free seat of the software. To find out more information about this promotion, call us at 877-333-4903. You'll talk to your account manager and they'll go over all the details with you. Okay, so all right, let's get back into it. So we have our routine here. This is our first tool is going to come in here. This is going to clear the majority of the material working from the outside in. Again, this is a 3-sided open pocket. If we wanted to use more of the adaptive style, we can come in here and use the adaptive rough. There are different ways that you can use adaptive roughing. You can use it for more side milling, where you're taking a shallow width of cut and an aggressive depth of cut, or you could also use it to take a very aggressive step over as well. So you could do like 100% step over, and with an offset style toolpath, you're not always able to get away with a 100% step over. So this will do a very aggressive cut to clear the majority of the material, and then we can come in here with the smaller tool and clean up our corners of what's left. Scott has a question. Did you say there was a video available online that walks you through the steps of selecting the pocket geometry, blanking out the part, and changing the edge lined into dash? Absolutely. If you search on YouTube, BobCAD Quick Tips, open pocketing in general, Scott, you're going to find multiple videos. So I would definitely recommend you consider watching that. Actually, if you want me to send you a copy of the video, I would gladly do so. I think that would be great to go through. All right, so this again is a 3-sided open pocket. So there's 3 sides of the part that we're trying to come in on. Again, using the dotted line method is a great way to work with this. All right, let's look at number 7. Okay, so number 7, this is another pocketing routine. This one is, instead of, there a lot of times you may want to come from the outside in. I know Larry was talking about that, coming from the outside in. Sometimes you're going to want to go from the inside out, and you may already have a void in your part. So there may already be a pocket or a hole within the part. So what you can do here is utilize that as an open pocket, but going in the other direction. So let's talk about that real quick here. Let's blank this out. Okay, we're going to go paste our feature in here. All right, I need the wireframe geometry, so I'm going to create a new layer. I'm going to do utilities, extract edges single. I'm going to click on this face here. I'll choose OK, and I'll blank it out. And really what I'm saying is this inside, there's already a void, or there's already a hole within the part. So we're going to make this a dotted line here. That is saying that's the open area, and we want it to go from the open area out. So we'll select our geometry here. Let's see. We'll select our geometry here. We're going to edit our feature. This is going to be an advanced pocket, adaptive. We'll drop the step over here. Make this 50%. We're also going to do adaptive, and we'll make this 15%. And then we will compute this one. So that's the nice thing about this The adaptive toolpath is you can work from the outside in. It could be one-sided open, it could be two-sided open, it could be three-sided open, it could be four-sided open, or you could work from the inside out. So it's just a really very dynamic feature that you can use in a lot of different ways. If you guys have any questions about that, go ahead and fire away. If this is if you're new to BobCAD or you want to learn more about it, you guys can always download a demo from our website, BobCAD.com. Let's see here. Raymond has a question. At the end of the seminar, can you verify the latest version will create a UCS from an MCS? I'm not sure what an MCS is, but we can create a UCS either in a three-point method or from a surface. And yeah, we can definitely go through that together. All right, here. So here we can see we have our open pocket routine. I probably want to drop our tool sides down a little bit, but you can see how it will work its way from the outside in, coming in and clearing as much of those star areas as possible. And then I think I have a rest routine here to come in and clean up what's left over. It may not, there may not have been anything left over for it. Okay, so again, that is an inside machine coordinate system. Okay, that's an inside pocket where you're pocketing from the inside out. All right, if there's any questions about that, go ahead and fire away. Otherwise, let's take a look at the next one. Okay, and this is, again, just another version of a rest machining routine. So we'll do a new job here. We're going to set our origin over in this corner. Okay, we'll paste our machining feature. I'm going to select my face that I want to work on. Let's clear that, pick our face. Okay, that looks good. We can compute the default, so we get an offset style pocket. We can compute the rest machining that's going to go in and try to clean up the corners there. What I'm going to do is come back in here. This one, you know, maybe we'll make it like a 1-inch cutter. And that will be like an offset routine. And then this one's a 1/4-inch cutter. And we're going to do adaptive, and we'll make it like a 10%, and we'll recompute. So you can use the larger tool to clear out the majority of the material, and then you can use a smaller tool to come in here and to clean up what's leftovers in the corners. Okay, so that's just another rest machine routine. If you guys have any questions about rest machining, go ahead and let us know. Otherwise, we're going to move on to the next one. Let's see what else we have here. I'm going to actually close out some of these files. So we did an offset pocket there. Let's see here. We did multiple pockets. You can do multiple pockets. Let's see here. We did a pocket with an island where we had some rest machining. So that's what we were looking at with that one. This one here, we did a one-sided open pocket, so you can work your way in from the outside. All right, we're going to close that one out. We got a let's see, this is a two-sided open pocket here. Again, so you can work from one side to the other, like if you're doing a slot or something like that. Hey, Leon, we'll see you next time. No big deal. Let's see here. We have a three-sided open pocket. So this way you could work your way in. There's four-sided as well, which I didn't have one set up for here today, but you could do a four-sided pocket. Let's go ahead and close that one out. You can do an inside pocket out. So this way you can work from the inside out. If you have a void, you can do that as well. And then let's see what we got here. This one, again, just coming in and picking up some corners. So you can use a smaller tool to come in and clean up what is left over in the corners. So let's see what else we're at. We're on 8. So let's go to 9. Again, this is just another pocketing routine where you have multiple pockets. Okay, so we can set up our job. From here, we can set our 0 position. Once we have our 0 position picked, I'm going to paste in my feature here. I'm going to select my geometry. All right, I'm going to compute. So that's the larger tool coming in and clearing up the majority of the material. And then I'll compute my rest machining. Go to Morning Al, great stuff, got to go. Please send me a copy. Keep up the awesome work. Thomas. Hey, thank you so much, Thomas. Great to see you here today. Good stuff. All right, so again, we have a larger tool coming in and clearing up the majority of the material, and then we're using a smaller tool to come in and clean up the corner. So again, this is rest machining, where you can use a larger tool to clear the majority of the material and then use a smaller tool to come in and clean up what's left over. Let's see, we got a 10 here. This one's kind of interesting. You know, you may have a pocket, and then you may have like an island on the wall here. So how do you go about doing this, you know? And you know, I don't know. It's kind of a tough one. I mean, it's not really tough, but you know, you got to think about different ways to approach this. If you are dealing with a pocketing scenario like this, there, you know, again, a couple of ways that you could think about it. What I'm going to do is I'm going to paste my feature in here again. All right, I'm going to select my boundary. Now, if I select this face here, then it's going to avoid this area. Okay, if I select this face here, then it would try to machine inside of that area, right? So that isn't necessarily going to work. So what you might consider is, you know, grabbing this loop here, okay, for the top of it, and then telling it to just go down to the top of this face here, all right? So we could do that in one pocket here, and what that will do is machine down to the top of that boss. So you've cleared the stock to the top of that boss, okay, or this island that's there. And then once you've done that, then what you can do is, you know, come in here and select that bottom face and machine to that face. Okay, so you know, there's a lot of approaches for this, but you know, if you have a multi-level here where you have a flat like that, that's coming out either three-side or some kind of land, you may pocket down to the top of that boss that's there, and then you may go in and machine from the bottom there, if that makes sense. Okay, so again, just kind of using some of the different tools that you have. You may come in here and just machine this area too. I know that you know, today's topic is about 2D pocketing, but another popular way, let me blank these out, to attack like this this surface here would be to use one of the 3D tool paths called Flatlands. And I went through this with a client here today, and it was very useful. We can come in with Flatlands, and Flatlands would allow us to target that area. Now, if I compute, let me loosen up some of the tolerances here. If I compute the defaults, what we're going to see is it will machine or like face all the flat areas of the part, which is not a bad thing. It's definitely not a bad thing, but it's cutting in areas that we don't want. So, you know, how do we restrict it so that it doesn't cut all over the place? You know, I would come in here and I'm going to do my parameters, and I would say pick top, and I could, you know, pick on the top of this, and I'll just make it slightly smaller, and then I could say pick bottom, and I could click on this edge and just add a little bit more. So I can pick two different levels that I'd be machining in, and then I'll compute that, and then now it's just going to target that one area there. Okay, and when you're using Flatlands, you have a couple of different patterns you could utilize. We could do a zigzag routine versus a zig, so this way the tool will stay down. We could also use like a parallel type, so you could do a parallel pattern, and this way it will work back and forth, and you can run it either 0 degrees or 90 degrees. You could do a adaptive pattern as well. So you have a couple of different patterns that you can utilize, but using the 3D Flatlands is a great way to attack that there. All right, sorry about this. All right, so excuse me for just a second there. Okay, so could you use the boundary of the hole? You know, we could come in here. I mean, honestly, like you could come in and just profile this area here. Could you use a boundary for flatlands? Yes, you could. You could select a boundary as well, Don. So that is another option there for you. Okay, so we got let's see, we're on 10. What else do we have? We have 11 here. Okay, so one of the other things, if you guys are dealing with round circles, whether they're through holes, they're counter bores, they could, I mean, it could be all kinds of scenarios. This is where we would use our spiral pocketing. We're generally going to use spiral pocketing for circular shapes. Again, it could be counter bores, it could be pockets, it could be for your soft jaws. I mean, there's all kinds of scenarios. We're going to paste our feature in here. Let's go ahead and select a boundary. Let me delete all these. We'll select this boundary here. We'll say OK. We're going to edit this feature for our patterns. We're going to use spiral for circular pockets. You're welcome, Ray. We'll compute this, and then we'll see we get a nice spiral routine there. Okay, now you can see this one has the floor, so when I selected it, I selected the floor of the model. If you didn't have the floor, what I would do is I would go to this edge here, and I would right-click, and I would do a loop selection, okay? And doing a loop selection, maybe I won't do a loop selection. Why would I wouldn't need a loop selection. I could just pick on the edge. I don't know what I'm thinking here, because it's just a circle, so I could pick just one edge. But if it was an irregular shape, then we wouldn't be doing a spiral pocket. So yeah, so we would just pick the edge is how that would work, and then when we want to pick our bottom, we could pick how deep we're going to go, and then compute that. And like I said, that'll get us a nice spiral. So if you have circular pockets or bosses, counter bores, things like that, you can use a spiral pocket for it, and it does a really good job. Let's see here, we have 11. All right, the last one we have here, this is just another irregular pocket. So we covered a lot of different pocket routines. We covered zigzag, we covered offset, advance, adaptive, spiral, and rest roughing. Those were all the pocket routines that we have. Again, we are running a promotion, a refer a friend promotion. So if you have a friend, a colleague, even an enemy that you feel could use some BobCAD software, call us today, 877-333-4903. You call in, you refer a friend, and you get a free seat of the software. So who couldn't want a better deal than that? So that is some great news there for you. If you haven't called already, call today. I'm sure you'll be glad that you did. Jason had a question. Can you control the depth of the cut with the spiral? Absolutely. All the pocket cycles, you can set an increment of depth. So you can go to your parameters page here. Under depths, you can set this to multiple steps, and then you can say how much per pass that you want to go, and then it will recalculate this, and then that way you can get multiple passes to get down to the bottom. So you can absolutely do that, Jason. If you have any other questions about that, let me know. This one again here, this is just another pocketing routine. Now, what I didn't cover here in my samples was more of like a boss type shape. So let's actually go back here and let's see what we can do. So we'll take let's look at our design tree. This one, let's delete this. Okay, let's bring this up. We're gonna do solid extrude cut. So we'll go from here to there. Let's make it, I don't know, a half inch down. All right, so that gives us this shape here. Okay, so this is where we may want to clear this stock from the outside in, okay, leaving this island standing here. So how would we control that? We'll do utilities, extract edges single. We'll click on this face. That's going to give us our wireframe, okay? From there, we can select our boundaries, which would be this boundary and this boundary. We're going to turn it into a dotted line. Now that we have that set up, we can run our stock wizard here. So we'll do new job. We'll set our 0 back in this corner here. Okay, we're going to paste in that machining feature. We'll select our boundary, and again, we'll use our dotted line for the open area, our inside boundary. We'll say OK. Let's see what we have this one set to. So we'll go to patterns. This one's going to be an adaptive routine. We'll go ahead and compute, and that will work its way in from the outside. Again, that would be a 4-sided open pocket. I hadn't shown one of those examples. Now, I did have some questions that came in, some files that came in. Let's see here. We have this one here, and we have this one here. Let's take a look at this. I don't know if Humberto, or did you make it into today's webinar? I'm not sure if you did. This is a sample file that he had sent in, and if you look at this file from above, you can see that we have some tapered walls. I had a lot of clients ask about tapered walls and tapered floor pocketing. There's a lot of pockets to cover in today's webinar, so I have about 10 minutes left. I don't know if that's enough time to get into this. I have another webinar scheduled for next week. If you guys haven't signed up for it, I'd recommend doing so. It has to do with profiling and the 3 types of profiles that we have: standard, contour ramping, and side roughing. And if you're dealing with tapered walled pockets like this, it's really going to come down to 2 different scenarios. Either you're going to load in some tapered tooling, or what you're going to do is use like a Z-level finish type routine. And I think a lot of people will agree that the tapered tooling is a good way to go. Let's see what we got here. Like in this example here, if these walls had draft on them, how would you go about that? Well, the pocket routine, we did a rough, and then we did a rest machining. So let's drop this down to like a 1/2 inch end mill. I guess it's a little bit tougher because of the corners on this one, but that's okay. So we'll drop this down. We're going to make this step over 50%. We'll recompute. All right, so this is going to go in and clear up the majority of the material. So we did this, and then in order to put the taper on the part, what we're going to do is edit our feature here. We're going to throw a finish pass on the wall, and then for our finish pass, we'll go into our tool crib and we'll look for a tapered cutter, and we'll add one in from the library. Either that, or we will make one ourselves. So we'll use a tapered cutter, so this way we can profile around the wall. Let's do something like this, and like that, and then we'll add like a little lead. Okay, and then we'll compute that. Let's see. Let's blank these other guys out. All right, let's modify our chain starts. I just want to put them right in the center instead of in these corners that they were in. We'll recompute, and then so using a tapered tooling, you can come in here and run against that wall and put a draft up against the wall. Okay, so if you have a tapered wall pocket, a really easy way to do that is just to run a profile against the wall. There's a lot of different ways that you could do that, but that is a good way to do it. Now, you could also come in, like in this sample here, you may say that you want to use like a Z-level finish type routine. Z-level finish, you'd be using a ball mill. Let's set this over here. So we would get into some of the 3D tool paths in order to do the taper. So you could say mill 3-axis. You could select your geometry here. You could use a Z-level finish type routine, set up a ball mill. You could work from the top down. You could go from the bottom up, run in bidirectional. And then what this will do is come in there and throw some toolpath down on the tapered walls, or tapered or vertical walls, and then that way you can machine them. Okay, so that's another way Another way of approaching this is with a 3-axis toolpath. I think if you're using tapered tooling, I think that is probably a little more beneficial for you because it's more efficient. When you get into some of the 3D toolpaths, there's a little more going on there as far as like how many passes that it takes in order to get down to the bottom. So when you start looking at runtime and efficiency, it could take a little bit longer. But here you can see with the Z-level finish, and there's some holes here. We might need to cap these surfaces. I've talked about this before with some of the 3D toolpaths. You'll see an option that says ignore holes. So I'll turn that on and recompute it. Sometimes that will ignore your holes. Your hole geometry has to meet a specific geometric condition. If it doesn't, then it's not going to read that as hole geometry. And that's what you'll see here is you can see how it wasn't able to read those as holes. So what would we do? We would just come in and generate some cap surfaces. Cap surfaces, you just select the edges of the circle here, or this counterbore. You just cap them up as such. By capping them, you can add that to your selection. So now let's do remove, select all, and then compute. So now what it will do is it will stop the toolpath from going down inside there. If you guys have any other questions about pocketing, we got just a few minutes left of the webinar, so go ahead and fire away. Again, this is the first time we've done a GoToMeeting webinar and a Facebook live stream at the same time. Kind of a lot going on for one person, but hopefully I've done a good job. If you guys feel like you got something out of today's webinar, definitely let me know. Like we talked about earlier, we do have a specific webinar promotion. It's the Refer a Friend promotion. If you're not a BobCAD customer and you and a buddy want to get a copy of BobCAD, this would be a great time to do so. Call 877-333-4903. Refer a Friend promotion with BobCAD. Friends, colleagues, even enemies, hey, we'd love to work with your people. So give us a call, 877-333-4903, and get yourself the latest copy of BobCAD and get the most out of it. Thank you so much, Pat, for showing up here today. Don has a question about tabs. Don, we have tabs in the software currently, so that is available as of right now. We'll go through that here in just a moment with you. So let me just finish up today's webinar recording, and then we can get into some questions after the webinar. So give me just a second. Again, I appreciate everybody spending some time with me here. Let's see here. I can't get to it, but anyways, refer a friend, give us a call. Thank you so much. We look forward to seeing you in next week's webinar. Next week's webinar is going to be about profiling, the 3 different kinds of profiles. So definitely love to see you there. Look forward to seeing you. Thank everybody so much for spending some time with us here today.